This conference will now be recorded.
So, very good evening, student. Today,
Yes,
I don't know. It shows like this sometime. I think it will be stable. Yeah, now it will be stable. So today we'll be discussing few numerical problems which are being asked in NEET exams and other competitive as well as board exam also. So this part we had already discussed logic circuits and digital circuits and logic gates, etc. We have discussed in the last class. So we have picked up few problems based on logic gates and digital circuits. So that is what we'll be discussing today. So see this question, first question. In the combination of following gates, the output of Y can be written in terms of A and B as. That means you have to find out the correct answer in terms of A dot B whole bar and all those things as you see here. These are the options. So look, before you solve, I'll tell you few tricks. Excuse me. So whenever there will be any not operation, whenever there will be any not operation, the output of not operation will be with a bar. Suppose not has only one input that we had discussed. Sorry, let me draw it properly. So this is not circuit symbol as you see here. So whenever you have not operation, the output will be always A bar or B bar, like that. Okay. And one thing, suppose you have A dot B whole bar. This that means A and B, and then this output of AND gate is fed to in NOT gate. So this can be written as A bar or B bar. So these are the things you should, or vice versa. Okay, both way it can be written. So here we have to see this A. So these are the NOT gates, these are AND gates, and this is OR gate. Let me write, this is AND, this is also AND, this is OR gate as you see, this is NOT gate, I'll write N only. So the input A goes here directly to AND gate, and again it goes to this also, this AND gate also through the NOT operation. So when you see for this AND gate, let us write here output Y1 and this output to be Y2. So what you get at Y1, so you have this as AND gate. So B is here, B bar, and this is A. So your input to this AND gate is A and B bar. So we can write A and B bar. So Y1 is A and B bar. Dot represents the AND operation. Now look this one. This is another AND gate. So for this AND gate, what are the inputs? input is this one A bar, and this input is directly coming here to this AND gate, so it is B. So you get here Y2 A bar dot B. So this is what you get. Okay. Now if you feed this Y1 and Y2 to this OR gate, what you get? Ultimately you will get Y is equal to Y1 or plus means or Y2. So let us write that. So A dot B bar. Acha, okay, so let me write A bar B first. A bar and B plus A and B bar. Okay, so this is how we get the result, or I can write it as, you can see this is matching with my output. So A dot B bar plus A bar dot means and, so I should read A and B bar plus A bar and B. So B, option B will be the correct answer for this question. Okay, so this is how we have to solve. Next question will take this one. The correct Boolean operation represented by the circuit diagram. So this is the inner circuit diagram of and or and NAND or NOR. This is the inner circuit diagram. Inner means, see, we are just feeding 0 or 1 or high state or low state, but there is a circuit to perform the operation of AND or NAND or NOR. So here such circuit is given. So this is actually, see, we are just drawing we are just drawing either AND like this, okay, or not like this, but inside it there will be transistor, there will be resistor, there will be LED, many other things inside, okay, to provide the correct operation. All right, look here in this circuit, there are two resistors are two resistors having resistance R, this one and this one, and this is LED. So this is one path for the current to flow because this is positive terminal of the battery, 6 volt, and this is the ground part. Okay, so this has high potential, this is at lower potential. So if I don't have these things, then current will directly flow through this, then LED will be glowing, right? And look here, so these are the input switches A1 and B1. So when these switches are closed like this, if the circuit, this circuit is closed circuit, then what will happen? Then current will actually flow through this and bypass the LED or this path. Then current will be 0 in this path, and through this path the whole current will flow, because this is simply a conducting wire. You look, these are conducting wire. This is a switch. This is conducting wire. This is also conducting wire, right? So conducting wire has very less resistance, and we know generally current prefers to flow through less resistive path. So you have two resistors over here, R, this R, and this LED also had some resistance. So if both these switches are closed means 1 and open means 0. If both are closed, then current will flow in this way. It will bypass this circuit or bypass the LED. So see you will not see the LED glowing. Okay, or suppose one switch is closed and this is open, then there will be no current flowing through this bypass circuit. Okay, either of this switch is open, then this circuit is not a continuous circuit. Okay, that's why the LED will glow, current will not flow through this circuit. Let us see now. So what is the operation like? Let me find out the truth table itself. AB, and then LED glowing means 1 and not glowing means 0. So I have a choice. Suppose I take both the switches open. 0 means open. Then if both the switches are open, then what we get here? We get LED glowing. That means we get a 1. Now look, I keep A closed. That means 1, and B 0. Then also LED glowing, because current will not flow through this way. Okay, circuit is not complete. Similarly, if I make this A off and then B on, then also we'll get LED glowing. Now look, if I make both these things on, then LED will not glow, right? LED will not glow. So look what we are getting here: 0 0 0 0. Oh, okay, let me interpret this truth table. This is A and B. A, B both. If I take A, B both, here there are options like AND. AND means when both are on, then only we will get output. Okay, so A and B will give you output when both are on. Okay, but in this case we will get 0. So that's why it is not the true one. Okay, but in this case again it is not OR also. Okay, let us see what is this. So if it is OR, then if either of excuse me, either of the switch A and B are on, we should get output. But here see last option what it is saying. So in the last option what it is saying actually, you know, you have A and B both on, but still you are getting output 0. Okay, so we can have either of this and this. Okay, let us take this as NAND means and bar. So that means what we get: A bar plus B bar. Okay, this we will get for the case of NAND. So look here, if A is equal to 1 in the input, then output we get A bar, that means 0, and B bar also we get 0. Okay, so these two will give you ultimately 0 result. Others we see, if I have 0 0, then I get 1 or 1. That means you should get 1 output. Again, if I take 1 0, let us see what we get. If we have 1 0, 1 means, see, A is 1 means 0. Okay, and B is 0 means it is 1. This is OR operation, so you will get 1. So when either of them is low or both are low, you should get high. So this is actually representing, at least we can see from here that it is representing NAND. Let us see why it is not NOR. NAND operation, it is supporting, this truth table is supporting non NAND operation. So that is the correct answer maybe. But let us just verify why it is not NOR. So NOR operation means, if you have A, then you have B. NOR means A or B, then whole bar. So this would give you A bar dot B bar. Okay. Now see, dot means AND operation. If I have 0 and 0, 0 0 means, look, 0 means 0 bar means 1, then 1. So this would give you 1. Now let us take this A as 1, 1 give you 0, and B is 0 means B gives 1. So this should give you 0. But here we have 1, 1, right? Okay. Again, if I have 1, 1, look, 1, 1 means 0 bar, and sorry, 0 and 0, that would give you 0. But we have, all right. So if we have 0 also, but other, these two operations are not correct. Okay. So it is actually, okay, let me conclude it. So it is not a NOT gate, sorry, not an AND gate. We have seen that neither it is NOR gate or nor it is NOR gate. Okay, it is not even NOR gate is also not represented by this. Only thing is NAND. This is actually NAND operation, because we have seen in case of NOR we get A or B whole bar means A bar and B bar. So if we take these operations, like when I have A is equal to 1, then it gives 0, and B 0 means it gives 1. This would give you 0, but we have 1. Similarly, if I take this as 1, sorry, this as 0, then you get 1 and somewhere it is 0. So it would give 0. But we have this two output. So this will satisfy only to this NAND gate. Okay, so this, then correct Boolean operation represented by the circuit diagram is a NAND gate. Okay, so this is how you have to solve this kind of problem. So this is a problem from NEET paper. Okay, previous year's NEET paper. Deepa, is it understandable? Are you getting my point? Okay. If you can't speak, you can write at least. I hope you are able to hear me. Okay, we are going to the next problem now. Okay. So this is a problem where you have been given a digital circuit. You can see that a circuit diagram here. So this is a NOT gate, this is another NOT gate, this is a NOR gate. You can see that this is OR followed by a bubble that will give you NOR operation. So you have to find out the correct truth table for this particular operation. We have to see what will be the correct truth table. Let me do one thing. Let us do one thing. Let us write what is Y. First of all, look, this is A. When it is A, upon having not operation of A, you will get A bar. Similarly, this will be B bar. So then for this particular gate, you have to inputs A bar and B bar. So you get A bar and B bar. A bar, this is OR. First you have to take OR. So B bar, and then this bubble means NOT operation. So what you get here, you get like this double bar. And see, this was OR, so this will be converted to NOT. Sorry, and operation. Okay, these are not included in your syllabus. Syllabus in the sense this kind of notations are not given in your NCERT textbook, but you can just learn from here that this double bar will give you ultimately A. Okay, that means you're taking A bar as input and taking again NOT operation of that. Suppose I have A is 1, then A bar is 0, then again I take 0 bar, that would give you 1. So in that way, when you take NOT operation of any input twice, you'll get the original signal back. Okay, that's why this is not, sorry, and. So ultimately you should get here Y is equal to A and B. That means it should act as an AND gate. It should act as an AND gate. It should act as an AND gate. Right? So AND gate means what? We know that truth table, right? For AND gate, see when both are on, then only you will get output. That means look where one gives you 1, that you have to see. So this is this second one here, 1 1 is 1. Let us see this is 1 1 0, then it is not the correct one. So this 3 also is giving 1 1 is 1. Let us take this to be like probable answer, but this 1 also will not be the answer, because 1 1 should give you 1. So this 3 and 2, these are actually giving you 1 1 as 1, because this is AND gate. So we have to now verify which between these 2 and 3 will be the correct one. Let us see for AND gate, when your both inputs are 0, you will get 0. When you have this as 1, this is 0, then also 0. When you have this is 0, 0 means low level or off, this is on, then also it is 0. When both are on, then only you will get output. So look which one is similar to our truth table. So this second one. Third one is also not true. Okay, because look here, AND gate means this is saying if either of A or B is on, then you will get like operation on. This is actually for OR gate. This third is actually for OR gate. It is not for AND gate. Okay, so then these are not the answers. Only the two will represent the correct operation for this given digital circuit. Okay, all right, so this is how you can solve problems. So I think you have learned here this one as new. Okay, see one thing, Deepa, you have to remember, when I have A or B and whole bar, you can break it as A bar and B bar, like that. Okay, you can do that. When you have A dot B whole bar, you can break it A bar or B bar, like that. These are the things you should remember. Okay, so A and B whole bar, you can write that as A bar or B bar. Okay, like that. All right, so we have solved this problem also. We'll go to the next one. So this problem seems to be a little bit tricky, right? Oh, just a minute. I have forgotten to give the options here. I'll just attach the option. Just a minute. Okay, these are the options, Deepa, for this question. See, in this question, let me tell you what is the question itself. See, the question is that these are three inputs A, B, C. They are varying with time. They are varying. They are not constant input. They are varying with time. At various interval of time, some of them are like A is on or B is off or C is on, kind of that. See, you can see this variation for C. The 0 to T2, it is always on or at high level. Similarly, if you see the B, 0 to T2, this time interval, it will be always low. And again, A, see 0 to T1, this interval, it is off or at low level. And T1 to T2 interval, it is on. Like that, you have to see the signals, input signals. Okay, input signals. And then uh, these input signals are fed to this particular digital circuit, and this digital circuit will actually give you particular operation. Okay, particular operation, digital operation. Let us find out what is that operation, or let us find out what is y output. What should be y or output here? Oh, let's write it here. So this is AND gate that we can see very nicely. This is an AND gate, and this is a OR gate finally. So from here, if B, so for this AND gate, what is the result? You get A and B. That is what you get from here. So from here, what you get? B and C. Okay, B and C whole bar. B and C whole bar. That would give you actually. Let us go up to here. Then we'll break it. So we have got two inputs for this and OR gate here. This is OR gate. So two inputs are. So let me write then what is Y. Y will be A and B, or B and C whole bar. If we break this, it can be written as A and B, or B bar, or C bar. Like that we can break. Okay, so from here we have to find out what will be the output waveform. This is kind of a waveform because it is varying with time. The magnitude of the inputs are actually varying with time, so the output will be doing the same, or maybe it can be a constant also. Okay, so whatever, see, uh, there are four options over here. See, this first option, what it is saying, that the output will be always at low level. So whether it is 0 to T1, or T1 to T2, or T2 to T3, so always output is 0 level. okay, or output is at low level. Let me first explain this second answer also, second option also. So what this second option is saying? See, second option is saying that for some time it would be low, then it will be again high for some interval. Then again for some interval it will be at low level. Finally, it will be at high level. So how many intervals we have? This is one. This is second interval. This is third, fourth interval, fifth interval, and sixth interval. So here output has only one, two, three intervals. Okay. So that means it is varying. Magnitude is varying with time. Third option is saying that it is always at high level, whatever interval you go for. Okay. Then the fourth is saying that for some interval it is at high level. Excuse me. Just a minute. Again for some time interval it is at low level. Again it is at high level. Again it is at low level. So this is how it varies. So we have to find out what it is. Let us see. Let us take some interval 0 to t1 interval. This interval I am seeing what are the inputs. See, A is at low level. That means A is 0. What is B? B is also 0 because it is up to T2 it is 0. So B is 0. What is C? C is at high level. You look, C is at high level up to T2. So in between 0 to T1 interval, A and B are 0 and C is at high level. It is 5. I'm just writing this 5 as 1. 5 means it is at high level. I'm taking this as 1. Now look, if I just put the values over here, inputs over here, what will get? Y output. See, A bar, like A and B both are 0, so this part will be 0, or this is B bar or C bar. B bar means 1, or C bar is 0, right? C is 1, then C bar will be 0. So ultimately what you get? Output as high level. That means high level I have taken 5 as 1, so it will be at high level. So between 0 to 1, this time interval, 0 to T1 interval, the output is becoming high. So this is one part. Then second part will take the interval T1 to T2. Like that, each interval will check. So first of all, we have to see during this interval, what are the inputs? So T1 to T2, this interval, A is actually high. That means A is 1. What is B? Let us see. B is actually T1, T2. See, this is the low level. So B and C, B is still at low level, so it is 0. What about C? C is still at high level. So C is 1. Now let us put all those here. So what is Y? Y will be A and B. That means A is 1 and B is 0. So that will give you 0. Then B bar or C bar. So B bar means B bar gives 1 and C bar gives you 0. So you get 1, that means at high level. So we have seen during 0 to T1 you get high level. T1 to T2 we get high level. I'll just write it here. 0 to T1, what is the result? 5 volt. Okay, so T1 to T2, what is the result? This is also 5 volt. Let us go to T2 and T3 interval. Like that, we'll have to check all the intervals. So T2 and between T2 and T3 interval, what is A? A is at 0 level. What is B? B is also, sorry, T2, T3, yes, this one. So this is at 0 level. A is low, but B is high. See, B is high. So B is 1. And what about C? During this interval, C is low. So you get C as 0. Now let us put it here. Oh, I have erased. Let me write the input. Sorry, output. Output was A and B, then B bar or C bar. This was the output, ultimate output over here, right? So let us let us put it here. So A and B, A and B, A is low and B is high. So it will give you 0. Then B bar means 0, but C bar means 1. So finally you get again Y is equal to 1 or it is at 5 volt level. So let me write T2, T3. This also gives you 5 volt. Okay, during this time interval also it is 5 volt. So I hope you are getting my point. So up to this much we have come, T2, T3. Then we will see T3, T4. Similarly, if we see T3, T4, so this is at high level. So T3 and T4 interval, I'll be writing directly. So T3, T4 interval, A is high, B is low. That means this part you will get 0. So B is, I'm sorry, both are high. I'm sorry. So you'll get 1 from there. This first part, both are high. A and B both are high. But at this interval, C is low. So you get B bar means 0, C bar is 1. Okay. So finally you will get 1, that means 5 volt. Again, T3, T4 interval, you get high level output. Similarly, if we see for T4, T5 and T5, T6 also, that will give you high level. Okay, I have already seen. You can just clarify that by yourself whether you are getting or not. For T4, T5, okay, or T5, T6 and beyond, you will get high only. Okay, so this third option will be the correct answer. You will get output always high, whatever may be this variation. Okay, so even though there is a variation in the input level, but you will get always output a high level. Okay, at high level. Okay, so this is actually a nice question, and actually this is the most, I think, from digital circuit or logic circuit, this is the most logical question, and it is a tricky one also. You have to be very very careful while seeing the inputs. Okay, while seeing the input you have to be very very careful. Like, see, during this time interval, which one is at high level, which one is at low level, those things you have to be attentively observing. Okay, then only obviously the logic operation or digital operation whatever would be given, you have to find out the final output first. Okay, like this we have written, and then we are just putting the inputs from this waveform here for various time interval. Okay, so then we are checking whether the output is low or high. So this is how you have to solve here for this uh, particular problem. You will get the answer 3. Third option will be the correct answer for this question. That means you will get always input level, sorry, output level high. Okay. So this, yeah. Deepa, you have any doubt or question from this digital part, or maybe from transistor part, etc.? Then you can ask me. Otherwise, I'll stop it here for today with this. Next class, we'll start with the communication system. In the next class, we'll start with communication system. Okay, so we have solved today some four questions, I think 4 or 5 questions, and I have explained nicely, elaborately how to solve this kind of problems. Now you should practice it. I hope I have given already a quiz paper on this. If not, I'll forward it very soon. Okay, so we'll stop it here for today.
This conference will now be recorded.